Using superposition, find VO in the circuit of figure. We have to find this VO in this circuit using superposition theorem. Solution. First of all, we will redraw the circuit. Now let's say VO is equal to, there are two independent sources. So VO is equal to V1 plus V2, where V1 and V2 are the voltage due to 9 volt and 3 volt respectively. 9 volt and 3 volt respectively. So to find V1, turn off. To find this V1, we will turn off this 3 volt. 3 volt. So circuit will look like this. This is a voltage source. So this will be short circuited, and this will be V1. Now if we apply nodal analysis, then let's say this is current I1, this is current I2, and this is current I3. So if we apply KCL here, so summation of all the entering current at this node is I3. I3 is equal to I1 plus I2. I1 plus I2. Now I3 is equal to 9 minus V1 by 3. 9 minus V1 by 3 is equal to I1. I1 is equal to V1 minus 0 by 1. So directly I1 is equal to V1 plus I2. I2 is equal to V1 minus 0 by 4 plus 9. 4 plus 5. This is equal to 9. So V1 by 9. I2 is equal to V1 by 9. V1 by 9. Now this will be 9 by 3 minus V1 by 3 minus V1 minus V1 by 9 is equal to 0. So this is equal to, this will be 3 minus 1 by 3 minus 1 minus 1 by 9 minus 13 by 9. So minus 13 by 9 is equal to, minus 13 by 9 V1 is equal to 0. So this is equal to 13 by 9 V1 is equal to 3. So this is equal to V1 is equal to 3 into 9 by 13. 3 into 9 by 13. 27 by 13. 27 by 13 volt is V1. V1 is equal to 27 by 13 volt. Next we have to find V2. So to find V2, this time we will turn off this 9 volt and consider 3 volt. Consider 3 volt and turn off 9 volt. So when we turn off 9 volt voltage source, then that will be a short circuit. and this will be this is V2, so this will be V2. Now again we will apply nodal analysis here. So let's say this is current I1, this is current I2, and this is current I3. So apply KCL at node V2. So summation of all the entering current, apply KCL at node V2. So I1 is equal to I2 plus I3. Now I1 is equal to 3 minus V2 by 1. 3 minus V2 by 1 is equal to I2. I2 is equal to V2 minus 0 by 3. V2 minus 0 by 3 plus I3. I3 is equal to V2 minus 0 by 4 plus 5 is equal to 9. So I3 is equal to V2 by 9. V2 by 9. Now this is equal to 3 by 1 minus V2 by 1. This will be minus V2 by 3. This will be minus V2 by 9 is equal to 0. So this is equal to 3 minus 1 minus 1 by 3 minus 1 by 9. So this is equal to minus 13 by 9. Minus 13 by 9. V2 is equal to 0. So this is equal to 3 is equal to 13 by 9 V2. So therefore V2 is equal to 3 into 9 by 13. 3 into 9 by 13. So 27 by 13. 27 by 13 volt. So V2 is also equal to 27 by 13 volt. Now what we have to find? We have to find VO. VO is equal to V1 plus V2. VO is equal to V1 plus V2. V1 is 27 by 13 volt. 27 by 13 plus V2 is also 27 by 13. So this is equal to 27 by 13 plus 27 by 13. 4.153. 4.153 volt. This is the value of VO. What we have to find? We have to find VO using superposition theorem. So this is the value of VO using superposition theorem. Use superposition to find VO in the circuit of figure. We have to find this VO in this circuit using superposition theorem. Solution. First of all, we will redraw the circuit. Now let's say VO is equal to, there are two independent sources. So VO is equal to V1 plus V2, where V1 and V2 are the voltages due to 6 ampere and 18 volt. 6 ampere and 18 volt respectively. So to find V1, we will consider 6 ampere. Consider 6 ampere and turn off 18 volt. Now when we turn off voltage source, then that will be a short circuit. So this will be short circuit and this will be V1. Now V1 is equal to, here we can apply current division rule. So V1 is equal to this resistance, which is 1 ohm, into current through this 1 ohm resistance. So this will be this current, which is 6 ampere, into its opposite branch resistance. So opposite branch resistance is 4 ohm by total. So total is 1 plus this is also 2 ohm parallel with 2 ohm. So this is equal to 1 ohm. So 1 plus 1 plus 4. So this will be 1 into 6 into 4 by 1 plus 1 plus 1 plus 1 plus 4. So this is equal to 4 volt. Therefore, V1 is equal to 4 volt. Next we have to find V2. To find V2, we will consider 18 volt and turn off 6 ampere. Now when we turn off the current source, that time it will be a open circuit. So to find, this will be V2. So to find V2, we will apply voltage division rule here. So this will be 18 volt into this resistance, which is 1 ohm, by total. Total will be 1 plus this 2 ohm parallel with 2 ohm. So this will be 1 ohm. So this 1 ohm. Then this 4 ohm. So this will be 18 into 1 by 1 plus 1 plus 4. 1 plus 1 plus 4. So this is 3 volt. Therefore, V2 is equal to 3 volt. V1 is equal to 4 volt and V2 is equal to 3 volt. And VO is equal to V1 plus V2. VO is equal to V1 plus V2. So this will be V1 is 4 plus 3. So this is 7 volt. Therefore, VO is equal to 7 volt. What we have to find? We have to find VO using superposition theorem. So this is the value of VO using superposition theorem. For the circuit in figure, find the terminal voltage VAB using superposition. We have to find this VAB using superposition theorem. Solution. First of all, we will redraw the circuit. Now as we can see that there are two independent sources and one source is dependent. So VAB is equal to VAB1 plus VAB2. where VAB1 and VAB2 are the voltages due to 4 volt and 2 ampere. 4 volt and 2 ampere respectively. Now to find VAB1, consider 4 volt and turn off 2 ampere. Now when we turn off current source, that time it will be a open circuit. This will be VAB1, this will be VAB2, this will be VAB1 also. Now we will apply, let's assume this is loop and with current I1. Now as we can see, there is no, this is an open circuit, so I1 is equal to 0. So apply KVL to the loop. So we will start from here. So this will be minus 4. Then this will be plus 10 into 0 plus 3 VAB1 plus VAB1 is equal to 0. Now this will be minus 4. This will be plus 4 VAB1 is equal to 0. So 4 VAB1 is equal to 4. Therefore, VAB1 is equal to 4 by 4, which is 1 volt. Next we have to find VAB2. So to find VAB2, consider 2 ampere current source and turn off 4 volt. Now when we turn off the voltage source, that time it will be a short circuit. So this will be short circuited. Now we will apply KVL to outer loop. So let's assume, let's say we will start from here. So this will be minus VAB. This will be VAB2 because we are finding VAB2. So this will be VAB2. This will be VAB2. So minus VAB2, then minus 3 VAB2, then this will be plus, this will be minus. So plus 10 current flowing through this resistor will be 2 ampere is equal to 0. So this will be minus 4 VAB2 plus 20 is equal to 0. This will be 4 VAB2 is equal to 20. So VAB2 is equal to 20 by 4. So this is 5 volt. Now we have the value of VAB1 and VAB2. VAB is equal to VAB1 plus VAB2. VAB is equal to VAB1 plus VAB2. VAB1 is 1 volt plus VAB2 is 5 volt. So this will be 6 volt. VAB is equal to 6 volt. What we have to find? We have to find VAB using superposition theorem. So this is the value of VAB using superposition theorem. Use the superposition principle to find IO and VO in the circuit of figure. We have to find this VO and this IO in this circuit using superposition principle or superposition theorem. As we can see that there are two independent sources and one dependent source. This is a current controlled current source. So solution, first of all we will redraw the circuit. Now let's say VO is equal to V1 plus V2, where V1 is the, or directly V1 and V2 is the voltages, or are the voltages due to 6 ampere and 30 volt respectively. Now to find V1, consider 6 ampere and turn off 30 volt. So to find V1, we will consider this 6 ampere current source and we will turn off this 30 volt voltage source. So this will be V1. This is a voltage source, so this will be short circuited when turned off. Now let's say this is node VA and this is node VB. So let's say this is a reference node which is grounded with 0 voltage. Let's say this is current I1, this is current I2. Now we will apply KCL at node VA. So summation of all the entering current at this node is 6 is equal to leaving current is IO plus I1. 6 is equal to IO is VA minus VB by 10. VA minus VB by 10 plus I1 is VA minus 0 by 40. VA minus 0 by 40. So this will be VA by 10 minus VB by 10 plus VA by 40 is equal to 6. So this will be 1 by 10 plus 1 by 40. 1 by 10 plus 1 by 40, 1 by 8 VA minus VB by 10, or 1 by 10 VB is equal to 6. Let's say this is equation number 1. Now we will apply KCL at node VB. Apply KCL at node VB. So summation of all the entering current at this node is IO plus 4IO. IO plus 4IO is equal to summation of all the leaving current. Leaving current is I2. So I2. So this will be 5IO minus I2 is equal to 0. So 5 into IO is VA minus VB by 10. VA minus VB by 10 minus I2. Now I2 is, this I2 is VB minus 0 by 20. VB minus 0 by 20 is equal to 0. So this will be 5VA by 10 minus 5VB by 10 minus VB by 20 is equal to 0. So this will be 1 by 2VA, and this will be minus 5 by 10 minus 1 by 20 minus 11 by 20 VB is equal to 0. Let's say this is equation number 2. Now solving equation 1 and 2. Solving equation 1 and 2, we get this will be 1 by 8 minus 1 by 10, 6. This will be 1 by 2 minus 11 by 20, 0. So VA is equal to 176 volt and VB is equal to 160 volt. What we have to find? We have to find V1. So V1 is equal to VA minus VB. V1 is equal to VA minus VB. So this will be 176 minus 160. 176 minus 160 is equal to 16. So V1 is equal to 16 volt. Next, what we have to find? V2. Now to find V2, we will consider this 30 volt voltage source. Consider 30 volt voltage source and turn off 6 ampere current source. Now when we turn off the current source, that time it will be a open circuit. Now let's say this is node VC. Let's say this is current I1. So apply KCL at node VC. Now when we apply KCL at node VC, so this will be all the currents are entering. So IO plus 4IO plus I1 is equal to 0. IO plus 4IO plus I1 is equal to 0. So IO is equal to, this is a reference node. So this will be 0 minus VC. 0 minus VC by 40 plus 10 is 50. Plus 4 into, or directly we will write, this will be 5IO plus I1 is equal to 0. So this will be 5 into IO is 0 minus VC by 50. 0 minus VC by 50 plus I1. Now I1 is equal to minus 30 because the polarity is opposite. So minus 30 minus VC by 20. Minus 30 minus VC by 20 is equal to 0. Now this will be minus VC by 10 minus 30 by 20 minus VC by 20 is equal to 0. So this is equal to minus 1 by 10 minus 1 by 20 minus 1 by 10 minus 1 by 20 minus 3 by 20 minus 3 by 20 VC minus 30 by 20 is equal to 0. So this is equal to minus 3 by 20 Vc is equal to 30 by 20. So Vc is equal to 30 by 20 into 20 by 3. This is minus. So this will be Vc is equal to 30 by 20 into minus 20 by 3. So this is equal to minus 10 volt. This is the value of Vc. What we have to find? We have to find this is not Vo, this is V2. We have to find V2. So V2 is equal to current into resistance. So current is IO into 10 ohm. IO into 10 ohm. Now IO is 0 minus Vc by 50. 0 minus Vc by 50 into 10. So Vc is minus 10. So minus of minus 10 by 50 into 10. So this is equal to, this minus minus will be plus. So 10 by 50 into 10. This is equal to 2 volt. This is the value of V2. Now Vo is equal to V1 plus V2. Vo is equal to V1 plus V2. V1 is 16 volt plus V2 is 2 volt. So therefore Vo is equal to, this is equal to 18 volt. Therefore Vo is equal to 18 volt. What else we have to find? We have to find Vo and Io. Now Io is equal to Vo into 10. Vo into 10. Io is equal to Vo into 10. Vo by 10, because voltage is equal to current into resistance. So Io is equal to Vo by 10, voltage upon resistance. Io is equal to Vo by 10. Vo is 18 by 10. So this is 1.8 ampere. Therefore Io is equal to 1.8 ampere. Determine Vo in the circuit of figure using the superposition principle. We have to find this Vo using superposition principle. Solution. First of all, we will redraw the circuit. Now as we can see that there are total 3 independent sources. 2 sources are voltage source and 1 source is current source. So let's say Vo is equal to V1 plus V2 plus V3. Since there are total 3 independent sources, so we have taken V1 plus V2 plus V3, where V1, V2 and V3 are the voltages due to 12 volt, 2 ampere and 19 volt and 19 volt respectively. So to find V1, To find V1, we will consider this 12 volt. Consider 12 volt and turn off all other sources. Since this is a current source, so this will be turn off and open circuited. Now this is a voltage source, so this will be turn off and this will be short circuited. Now let's say this is node VA and this is node VB. Let's say this is current I1, this is current I2, this is current I3 and this is current I4. Let's say this is reference node grounded with 0 voltage. This is 0 volt. So apply KCL at node VA. So summation of all the entering current at this node. Let's say this is current IO. This is current IO. So apply KCL at node VA. So summation of all the entering current. Entering current at this node is I1. Summation of leaving current. Leaving current is I2 plus IO. I2 plus IO. Now I1 is equal to 12 minus VA by 6. 12 minus VA by 6 is equal to I2 is VA minus 0 by 3. VA minus 0 by 3 plus IO. IO is equal to VA minus VB by 5. VA minus VB by 5. So this will be 12 by 6 minus VA by 6 minus VA by 3 minus VA by 5. This will be plus VB by 5 is equal to 0. So now this will be 2. This will be minus 1 by 6 minus 1 by 3 minus 1 by 5 minus 7 by 10 minus 7 by 10 VA plus VB by 5 is equal to 0. So this will be minus 7 by 10 VA plus VB by 5 is equal to minus 2. Let's say this is equation number 1. Now we will apply KCL at node VB. Apply KCL at node VB. So entering current at this node is IO. Only IO is the entering current and leaving current at this node is I3 plus I4. I3 plus I4. Now IO is equal to VA minus VB. VA minus VB by 5. VA minus VB by 5 is equal to I3. I3 is equal to VB by 0. VB minus 0 by 12. VB minus 0 by 12 plus I4. I4 is equal to VB minus 0 by 4. VB minus 0 by 4. So this will be VA by 5 minus VB by 5 minus VB by 12 minus VB by 4 is equal to 0. So this will be VA by 5. This will be minus 1 by 5 minus 1 by 5 minus 1 by 12 minus 1 by 4 minus 8 by 15. VB is equal to 0. Let's say this is equation number 2. Now we have equation number 1 and equation number 2. So solving equation 1 and 2, we get mod 5 1. This will be minus 7 by 10 1 by 5 minus 2. From equation 2, this will be 1 by 5 minus 8 by 15 0. So this is equal to VA is equal to 3.2 volt and VB is equal to 1.2 volt. What we have to find? We have to find V1. This is not VO, this is V1 because we are finding V1. So this is V1 and V1 is equal to VA minus VB. V1 is equal to VA minus VB. So this is equal to 3.2 minus 1.2. 3.2 minus 1.2 is equal to 2 volt. Therefore, V1 is equal to 2 volt. Next, what we have to find? We have to find V2. To find V2, we will consider this 2 ampere current source. Consider 2 ampere and turn off all other sources. All other sources since this is a voltage source, so this will be turned off and short circuited. Also, this is a voltage source, so this will be turned off and short circuited. So this will be also this will be V2 because we are finding V2. This will be V2. So as we can see that this 6 ohm parallel with 3 ohm. So this will be 6 into 3 by 6 plus 3. 6 into 3 by 6 plus 3. So this is equal to 2 ohm. Also this 4 ohm parallel with 12 ohm. So 4 into 12 by 4 plus 12. 4 into 12 by 4 plus 12. So this is equal to 3 ohm. Now this 2 ohm series with 3 ohm. So this will be 5 ohm. So let's redraw the circuit. This will be 5 ohm parallel with 5 ohm. This will be 5 ohm. Now, since both the resistors both the resistances are of equal value, so current will be divided equally. So V2 is equal to current into resistance. So current is 1 ampere and resistance is 5 ohm. So therefore V2 is equal to 5 volt. V2 is equal to 5 volt. Next we have to find V3. So to find V3, we will consider this 19 volt. Consider 19 volt and turn off all other sources. Since this is the current source, so this will be turn off and this will be open circuited. This is a voltage source, so this will be turn off and short circuited. Now we have to also, this will be V3 because we are finding V3, so this will be V3. So we can solve this using nodal analysis or using voltage division rule. As we can see that this 3 ohm parallel with 6 ohm, so this will be, we have already calculated this, 2 ohm. This will be 2 ohm. Now this 2 ohm is in series with 5 ohm. So this will be 7 ohm. This will be 7 ohm. This 7 ohm parallel with 12 ohm. So this will be 7 ohm parallel with 12 ohm. So 7 into 12 by 7 plus 12. 7 into 12 by 7 plus 12. This is equal to 84 by 19. 84 by 19 ohm. So this will be 84 by 19 ohm. Now we have to find voltage across this resistance. So this will be, let's say this is voltage V3. So V3 is equal to, this will be this resistance which is 84 by 19 into 19 by total. Total is 84 by 19 plus 4. So this will be 84 by 19 into 19, then 84 by 19, 84 by 19 plus 4. So this is equal to 9.975. 9.975 volt. Now we have this voltage which is 9.975 volt. We have to find this V3. So V3 is equal to, let's change its name. This is not V3. This is, let's say this is V3 prime. So this is V3 prime. V3 is equal to, this V3 is equal to this voltage. Now the polarity is opposite, so this will be minus 9.975 into this resistance, which is 5 ohm, divided by 5 plus this series resistance, which is 2 ohm. So this will be minus 9.975 into 5 by 5 plus 2. So this is minus 7.125 volt. This is the value of V3. V3 is equal to minus 7.125 volt. So VO is equal to V1 plus V2 plus V3. VO is equal to V1 plus V2 plus V3. Now V1 is equal to 2 volt plus V2 is equal to 5 volt plus V3 is equal to minus 7.125 volt. So this will be 2 plus 5 plus minus 7.125. 2 plus 5 plus minus 7.125. So this will be minus 0.125 volt. This is the value of VO. What we have to find? We have to find VO using superposition principle or superposition theorem. So this is the value of VO using superposition principle. Use superposition to find VO in the circuit of figure. We have to find this VO using superposition theorem. Now as we can see that there are 1, 2 and 3 independent sources. 2 sources are current source and 1 source is voltage source. So solution. First of all, we will redraw the circuit. Since there are total 3 independent sources, so VO is equal to V1 plus V2 plus V3, where V1, V2 and V3 are the voltages due to 2 ampere, 4 ampere and 12 volt respectively. Now to find V1, we will consider 2 ampere current source. Consider 2 ampere and turn off all other sources. Since this is a current source, so this will be turn off and open circuited. This 12 volt is the voltage source, so this will be turn off and short circuited. This will be V1 because we are finding V1. So this is V1. Now to find V1, let's say this is current I1. V1 is equal to current into resistance. So current is I1 and resistance is 5 ohm. So to find I1, we will apply current division rule. So from current division rule, I1 is equal to opposite branch resistance, which is 10 ohm, into this current, which is 2 ampere, by total resistance, which is 10 plus 8 plus 5. 10 plus 8 plus 5. So this is equal to 10 into 2 by 10 plus 8 plus 5. 20 by 23. 20 by 23 ampere is the value of I1. We have to find V1. So V1 is equal to 20 by 23. 20 by 23 into 5. This is equal to 4.34. 4.34 volt is the value of V1. 4.34 volt. Next we have to find V2. So to find V2, we will turn off this 2 ampere and 12 volt and consider 4 ampere. To find V2, consider 4 ampere and turn off all other sources. Since this is a current source, so this will be open circuited. This is a voltage source, so this will be short circuited. Now we have to find also this will be V2, because we are finding V2, voltage due to 4 ampere current source. So V2 is equal to, let's say this is current I2. So V2 is equal to I2 into 5 ohm. So this will be, you have to find this current, which is I2. So we will apply current division rule. So from current division rule, I2 is equal to this current, which is 4 ampere, into opposite branch resistance, which is 8 ohm, by total resistance, which is 8 plus 10 plus 5. 8 plus 10 plus 5, because this 5 ohm is in series with this 10 ohm. So this will be 4 into 8 by 8 plus 10 plus 5. 32 by 23. 32 by 23 ampere. We have to find V2. V2 is equal to 32 by 23 into 5 ohm. So this is equal to, answer into 5. 6.956. 6.956 volt. Therefore, V2 is equal to 6.956 volt. This is the value of V2. We have the value of V1. We have the value of V2. Next, we have to find V3. So to find V3, we will consider this 12 volt. consider 12 volt voltage source and turn off all other sources. Turn off all other sources. Now when we turn off this current source, this will be open circuited. When we turn off this current source, this will be open circuited. Also this will be V3 because we are finding V3 voltage due to this 12 volt voltage source. So V3 is equal to, here we will apply voltage division rule. So apply voltage division rule. So V3 is equal to this voltage. Now we can see that the polarities are opposite. So this will be minus 12 into this resistance, which is 5 ohm, by total resistance, which is 8 plus 10 plus 5. 8 plus 10 plus 5. So this is equal to minus 12 into 5 by 8 plus 10 plus 5. Minus 2.60. Minus 2.60 volt. Minus 2.608 volt. So therefore V3 is equal to minus 2.608 volt. Now we have the value of V1, V2 and V3. What we have to find? We have to find VO using superposition theorem. So VO is equal to V1 plus V2 plus V3. VO is equal to V1 plus V2 plus V3. So V1 is equal to 4.34 volt. 4.34 volt plus V2 is equal to 6.956. 6.956 volt plus V3 is equal to minus 2.608. So this is equal to 4.34 plus 6.956. Then this will be minus 2.608. 8.688. 8.688. The unit of voltage is volts. So therefore VO is equal to 8.688 volt. Apply the superposition principle to find VO in the circuit of figure. We have to find this VO in this circuit using superposition principle. As we can see that there are 1, 2 and 3 independent sources. So solution. First of all, we will redraw the circuit. Now let's say VO is equal to V1 plus V2 plus V3, where V1, V2 and V3 are the voltages due to 20 volt voltage source, 2 ampere current source and 1 ampere current source respectively. So to find V1, we will consider 20 volt. Consider 20 volt and turn off all other sources. Now when we turn off, we are considering this 20 volt and we will turn off other sources. So as we can see that this is a current source, so this will be open circuited. Also this is a current source, so this will be open circuited. Now we have to find this. Also this will be V1, not VO, this will be V1 because this is the voltage due to this 20 volt voltage source. So this will be 4 plus 2, this will be 6. This will be 6 ohm. Now this 6 ohm parallel with 6 ohm. So this will be 6 ohm parallel with 6 ohm. That will be half. So that is 3 ohm. Now here we can apply voltage division rule. Voltage division rule or voltage divider rule. So V1 is equal to this voltage which is 20 volt into this resistance which is 3 ohm divided by total 3 plus 3. This 3 plus this 3. So this will be 20 into 3 by 3 plus 3. So it is 10 volt. So therefore V1 is equal to 10 volt. Next we have to find V2. So to find V2, we will consider this 2 ampere. Consider 2 ampere current source and turn off all other sources. Now this is a current source, so this will be turn off and open circuited, and this is a voltage source, so this will be turn off and short circuited. Now we have to find also this will be V2, not VO, this will be V2. So now similarly this is 4 plus 2, this will be 6 ohm, 6 ohm parallel with 6 ohm, so this will be 3 ohm. This 6 ohm parallel with 6 ohm, so this will be 3 ohm. Now we have to find current through this. Let's say this is current I2. So apply current division rule. Current division rule or current divider rule to find I2. So if we found I2, then from that we can get the value of V2. So I2 is equal to this current which is 2 ampere, so it is in opposite direction, so this will be minus 2, then into opposite branch resistance which is 3 ohm, so 3 ohm divided by total resistance which is 3 plus 3, so this will be minus 2 into 3 upon 3 plus 3. So this is minus 1. Minus 1 ampere is the value of I2 from this we have to find V2. So V2 is equal to this current I2 into 3 ohm. So this will be I2 is -1 into 3. This will be -3 volt. Therefore, V2 is equal to -3 volt. Next, we have to find V3. So to find V3, we will consider this 1 ampere current source and turn off all other sources. Consider 1 ampere and turn off all other sources. So this will be turn off and open circuited because this is a current source, and this is turn off and short circuited because this is a voltage source. Now we have to find this V. Also this will be V3, not VO, because this is the voltage due to this 1 ampere current source. Here this 4 ohm is in parallel with this 1 ampere, so we will use source transformation here. We will convert this current source into its equivalent voltage source. So this will be this current source will be converted into its equivalent voltage source. I will redraw this 4 ohm resistance. So this is 4 ohm, and here its equivalent voltage source. This will be positive, this will be negative. So this will be voltage source is equal to V is equal to I into R. I is 1 ampere. So V is equal to I into R. So I is 1 ampere into resistance is 4 ohm. So this will be 4 volt. This voltage source is of 4 volt. Now we will erase this current source. Now as we can see that this 6 ohm is in parallel with this 3 ohm. So 6 ohm parallel with 3 ohm, this will be 6 into 3 by 6 plus 3. 6 into 3 by 6 plus 3. This is 2 ohm. 2 ohm. So this will be this will be 2 ohm. Voltage across both the resistances will be same. This will be 2 ohm. Now here we can apply KVL or voltage divider rule. So apply voltage division rule to find V3. So V3 is equal to this voltage, which is 4 volt, into this resistance, which is 2 ohm, divided by total resistance 2 plus 2 plus 4. 2 plus 2 plus 4. So this will be 4 into 2 by 2 plus 2 plus 4. So this is 1 volt. V3 is equal to 1 volt. Now what we have to find? We have to find this VO, which is equal to V1 plus V2 plus V3. VO is equal to V1 plus V2 plus V3. So V1 is 10 volt plus V2 is minus 3 volt plus V3 is 1 volt. So this will be 10 minus 3 plus 1. So this is 8 volt. Therefore, VO is equal to 8 volt. What we have to find? We have to find VO using superposition principle. So this is the value of VO using superposition principle or superposition theorem. For the circuit in figure, use superposition to find I. Calculate the power delivered to the 3 ohm resistor. We have to find this I and power delivered to this 3 ohm resistor using superposition theorem. There are 3 independent sources in this circuit. Solution. First of all, we will redraw the circuit. Now, let's say I is equal to I1 plus I2 plus I3. Since there are total 3 independent sources, so we have taken I1 plus I2 plus I3. Where I1, I2 and I3 are the currents due to 20 volt, 2 ampere and 16 volt respectively. Now to find I1, we will consider 20 volt. To find I1, consider 20 volt voltage source and turn off all other sources. So this will be this I will be I1 and we are turning off all other sources except 20 volt. So this is the current source. So this will be turn off and open circuited. This is a voltage source. So this is turn off and short circuited. Now we have to find this I1. So to find I1, let's find I first. So as we can see that this 1 ohm is in series with this 3 ohm. So this will be 4 ohm. Now this 4 ohm parallel with this 4 ohm. So this will be 2 ohm. Now this 2 ohm series with 2 ohm. So this will be total resistance 4 ohm. We have the value of resistance as 4 ohm and voltage is 20 volt. We have to find current I. So from this we can find I is equal to V by R. V is 20 and R is 4. So current is 5 ampere. Now we will redraw this circuit again. This value is 5 ampere. We have to find this I1. I1 is equal to opposite branch resistance. So opposite branch resistance is this 4. This current 5 ampere first, 5 into opposite branch resistance, which is 4 by this 4 plus 4. 4 plus 4. So this will be 5 into 4 by 4 plus 4. 2.5 ampere. 2.5 ampere. So I1 is equal to 2.5 ampere. Next we have to find I2. So to find I2, we will consider 2 ampere current source. To find I2, consider 2 ampere current source and turn off all other sources. So now we will consider this 2 ampere and turn off all other sources. Since this is a voltage source, so this will be turned off and short circuited. Also, this is a voltage source, so this will be turned off and short circuited. Now we have to find, also this will be I2. We have to find this I2. So let's say this is node. Or we can find using current division rule, as we can see that this 2 ohm parallel with this 4 ohm. We will circuit. So this 4 ohm parallel with 2 ohm. So this will be 4 into 2 by 4 plus 2. 4 into 2 by 4 plus 2. 1.3 ohm. This will be 1.3 ohm. Then now as we can see, this 1.3 ohm is in series with this 3 ohm. So this will be 4.3 ohm. And this will be short circuited directly. Now we have to find this current I2. So apply current division rule to find I2. So I2 is equal to this current, which is 2 ampere, into opposite branch resistance. Opposite branch resistance is 1 ohm by total. So 1 plus 4.3. So this will be 2 into 1 by 1 plus 4.3. So this is 20 by 53. 20 by 53 ampere. This is the value of I2, 20 by 53 ampere. Next we have to find I3. So to find I3, we will consider this 16 volt voltage source. Consider 16 volt and turn off all other sources. All other sources we are considering this 16 volt and we will turn off all other sources. So this is a current source, so this will be open circuited. This is the voltage source, so this will be short circuited. And this will be current I3. So to find I3, first we will find this current. As we can see, this 2 ohm is in parallel with this 1 plus 3. This is 4 ohm. So 2 ohm parallel with 4 ohm. This is 4 ohm. So this will be 2 into 4 by 2 plus 4. 2 into 4 by 2 plus 4. 1.33. 1.33 or 1.3 ohm. So this will be 1.3. Now 1.3 is in series with 4 ohm. So this will be total resistance. R is equal to 5.3. V is equal to 16 volt. We have to find I. So I is equal to 16 by 5.3. So 5.3. So this will be 16 by 5.3. 3.01. So this will be 3.01 ampere. This will be minus 3.01 ampere because the polarity is opposite and the I3 direction is in this direction. So this will be minus 3.01 ampere. Now here we will apply current division rule. So I3 is equal to opposite branch resistance, which is this 2 ohm into this current, which is minus 3.01 ampere divided by total resistance. Total resistance will be 2 plus 4. 2 plus 4. So this will be 2 into minus 3.01 divided by 2 plus 4. Minus 1 point or minus 1 directly, minus 1 ampere. So I3 is equal to minus 1 ampere. Now what we have to find? We have to find I is equal to I1 plus I2 plus I3. I is equal to I1 plus I2 plus I3. Now I1 is 2.5 ampere, 2.5 ampere, and I2 is 20 by 53. So 20 by 53 plus I3. I3 is minus 1 ampere. So this will be 2.5 plus 2.5 plus 20 by 53, then minus 1. So this will be 1.877 ampere. This is the value of I. 1.877 ampere. Then what we have to find next? Use superposition to find I and power delivered to the 3 ohm resistor. We have to find the power delivered to this 3 ohm resistor. So this will be power is equal to I square into R. So R is 3 ohm. So this will be I square is 1.877 square into 3. 1.877 square into 3. 10.56 power is equal to 10.56. The unit of power is watt. So watt. Given the circuit in figure, use superposition to get I/O. We have to find this I/O using superposition theorem. Solution. First of all, we will redraw the circuit. Now as we can see that there are total 1, 2 and 3 number of sources, independent sources. 2 sources are current source and 1 source is voltage source. So let's say I/O is equal to I/O prime plus I/O double prime plus I/O triple prime. This I/O where I/O prime, comma I/O double prime, comma I/O triple prime are the current due to 12 volt, comma 4 ampere and 2 ampere respectively. So to find I/O, we will consider this 12 volt. Consider 12 volt and turn off all other sources. Since this is a current source, so this will be turned off and open circuited. This is also a current source, so this will be turned off and open circuited. Now we have to find this I/O. So this I/O is the, first we will find equivalent resistance. Now as we can see that this 3 ohm, 2 ohm and 5 ohm are in series. So this will be 3 plus 2, 5, 5 plus 5, 10. This will be 10 ohm. Now this 10 ohm is in parallel with this 10 ohm. So this will be 5 ohm. Now this 5 ohm is in series with 4 ohm. So this will be resistance is equal to 4 plus 5 is equal to 9 ohm. Voltage is 12 volt and we have to find this current I/O. So I/O is equal to V by R. So V is 12 and R is 9. So this will be 12 by 9. So it is 4 by 3 ampere. This is not I/O, this is I/O prime. This is also I/O prime. I/O prime is the current due to this 12 volt voltage source. So I/O prime is equal to 4 by 3 ampere. Then next we have to find I/O double prime. So to find I/O double prime, we will consider this 4 ampere. Consider 4 ampere current source and turn off all other sources. So this will be I/O double prime first of all. Now this is a voltage source, so this will be short circuited. And this is a current source, so this will be open circuited. Now this IO will be, IO double prime will be, as we can see, this 2 ohm is in series with 5 ohm, so this will be 7 ohm. Now this 7 ohm, this will be 4 ohm parallel with 10 ohm. So this is equal to 4 into 10 by 4 plus 10. 4 into 10 by 4 plus 10. So this is equal to 20 by 7. 20 by 7 ohm. Now this 20 by 7 ohm is in series with, this will be like this. This will be 20 by 7 ohm. Now this 20 by 7 ohm is in series with 7 ohm. So 20 by 7 plus 7 is equal to 69 by 7. 69 by 7 ohm. So this whole will be, it will be like 69 by 7 ohm. Now we have to find, first we will find this current. Let's say this is current IA. So IA is equal to this current, which is 4 ampere, into opposite branch resistance, which is 3 ohm, by total 3 plus 69 by 7. So this will be 4 into 3 by 3 plus 69 by 7. So this will be 14 by 15. 14 by 15 ampere. This is the value of IA. We have to find this current IO. This is not IO, this is IO double prime. This IO double prime. Now we have the value of this current. So for simplicity, let's erase this. So this will be like this current, and this current is IA. This is current IA, and we have to find this current IO double prime. We have the value of IA. We have to find IO double prime. So from this IO double prime, we will apply current division rule. So IO double prime is equal to this current, which is 14 by 15. 14 by 15 is the value of IA. So this current into opposite branch resistance, which is 10 ohm. So this will be 10 ohm. 10 by 10 plus 10 plus 4. Also, the direction of IA and IO double prime is opposite, so this will be minus. Now this will be 14 by 15 minus 14 by 15 into 10 by 10 plus 4. So this will be minus 2 by 3 ampere. This is the value of IO double prime. IO double prime is equal to minus 2 by 3 ampere. Next, we have to find IO triple prime. So for finding IO triple prime, we will consider 2 ampere current source. To find IO triple prime, we will consider this 2 ampere current source, 2 ampere, and turn off all other sources. Turn off all other sources. So when we turn off this current source, this will be open circuited. And when we turn off voltage source, this will be short circuited. Now we have to find this IO. This will be IO triple prime. So to find IO triple prime, first we will find this current. Let's say this is current IB. This is current IB. So this will be IB is equal to this current, which is 2 ampere, into opposite branch resistance. So opposite of this branch is 5 ohm by total resistance, which is this 5 plus this will be 2 plus 3 plus this will be 4 ohm parallel with 6 ohm. So we have already calculated this. Okay, we will again calculate this. 4 ohm parallel with 10 ohm. So 4 into 10 by 4 plus 10. This will be 20 by 7. So 20 by 7. So this will be 5 plus 2 plus 3 plus 20 by 7. So this will be 2 into 5 by 5 plus 2 plus 3 plus 20 by 7. So it is 7 by 9. 7 by 9 ampere is the value of IB. Now we have to find IO triple prime. So IO triple prime will be equal to this current, which is IB. IB and IO triple prime are in opposite direction. So this will be minus 7 by 9 into opposite branch resistance, which is 10 ohm. So this will be 10 divided by total. So total will be 10 plus 4. So this will be minus 7 by 9 into 10 by 10 plus 4. 10 plus 4 minus 5 by 9. Minus 5 by 9 ampere. This is the value of IO triple prime. Now we have the value of IO prime, IO double prime, and IO triple prime. What we have to find? We have to find IO using superposition. So IO is equal to IO prime plus IO double prime plus IO triple prime. So this will be IO prime is 4 by 3 ampere. 4 by 3 plus IO double prime. IO double prime is minus 2 by 3. Minus 2 by 3 ampere. And IO triple prime is minus 5 by 9 ampere. So this will be 4 by 3 minus 2 by 3, then minus 5 by 9. This will be 1 by 9 ampere is the value of I0, or I0 is equal to 0.111 ampere. This is the value of I0. Use superposition to obtain Vx in the circuit of figure. We have to find this Vx in this circuit using superposition theorem. Solution. First of all, we will redraw the circuit. Now, as we can see, there are 1, 2 and 3 independent sources. So, let's say Vx is equal to Vx1 plus Vx2 plus Vx3, where Vx1, Vx2 and Vx3 are the voltages due to 90 volt, 6 ampere, 40 volt respectively. Now to find Vx1, we will consider this 90 volt. To find Vx1, consider 90 volt and turn off all other sources. All other independent sources. Now when we turn off this current source, this will be open circuited, and this will be a voltage source, so this will be short circuited, and this will be Vx1. Now as we can see that this 30 ohm parallel with this 20 ohm, so this will be 30 into 20 by 30 plus 20. So it is 12 ohm. Now we have to find this Vx1. First we will find voltage across this resistor. As we can see that this 12 ohm is in series with this 10 ohm. So this will be 10 plus 12, 22 ohm. Now this 22 ohm parallel with 60 ohm. So this will be 22 into 60 by 22 plus 60. 22 into 60 by 22 plus 60. 16.09 ohm. Now this will be 16.09 ohm. Now here we will apply voltage division rule. So this whole will be 16.09 ohm. So voltage across this 16.09 ohm will be, let's say this voltage is V 16.09 ohm. So this is equal to this voltage, which is 90, into this resistance, which is 16.09 by total. Total will be 16.09 plus this 30 ohm. So this will be 90 into 16.09 by 16.09 plus 30. 31.42. 31.42 volt is the voltage across this resistor. Now we have to find this Vx1. So to find Vx1 will be equal to this voltage. Here the voltage is 31.42. So 31.42 into, we have to find resistance, we have to find voltage from this resistor. So 10 ohm divided by total. So total will be 10 plus 12. 10 plus 12. So this will be 31.42 into 10 by 10 plus 12. 14.281. voltage. So therefore Vx1 is equal to 14.281 volt. Next we have to find Vx2. So to find Vx2, we will consider this 6 ampere current source. To find Vx2, consider 6 ampere and turn off all other sources. So we will consider this 6 ampere and turn off this voltage source and this voltage source. Now when we turn off voltage source, so this will be short circuited. Now we have to find this Vx. This will be Vx2. So as we can see that this 30 ohm parallel with 20 ohm. So this will be 30 ohm parallel with 20 ohm will be 12 ohm. 12 ohm. Also this 30 ohm parallel with this 60 ohm. So this will be 30 into 60 by 30 plus 60. So it is 20 ohm. So this will be 20 ohm. Now this 12 ohm is in parallel with this 10 plus 20, which is 30 ohm. Or directly we can find using current division rule. Let's say this is current I 10 ohm. So apply current division rule. So using current division rule, I 10 ohm is equal to this current, which is 6 ampere, into 6 ampere into opposite branch resistance. So opposite branch resistance is 12 ohm. 12 ohm by total. So total will be 12 plus this 10 plus 20. So this will be 6 into 12 by 12 plus 10 plus 20. 1.714. 1.714 is the value of I 10 ohm. Now we have to find Vx2. So Vx2 is equal to current into resistance. So resistance is 10 ohm and current is I 10 ohm. But the direction of current is opposite to the polarity of this Vx2. So this will be minus I 10 ohm. So minus I 10 ohm. So this will be 10 into, this will be minus 1.714. So therefore Vx2 is equal to 10 into minus answer. So 17.14. 17.14 volt is the Vx2. Next we have to find Vx3. So to find Vx3 we will consider 40 volt voltage source. To find Vx3, consider 40 volt voltage source. 40 volt voltage source and turn off all other sources. So this will be turn off and short circuited. This will be turn off and open circuited. And this will be Vx3. Now to find Vx3, as we can see that this 60 ohm parallel with 30 ohm. So this will be 30 ohm parallel with 60 ohm will be 20 ohm. This will be 20 ohm. Now first we will find voltage across this resistor. So this will be, we have to find its equivalent resistance first. So this 20 plus 20 plus 10 will be 30. 30 ohm parallel with 30 ohm. So this will be 15. This whole will be 15 ohm. Now the voltage across this 15 ohm will be V15 ohm is equal to this voltage 40 into this resistance, which is 15 by 15 plus 20. So this will be 40 into 15 by 15 plus 20. 17.14. 17.14 volt is the voltage across this resistor. Now we have to find this voltage across 10 ohm. So this will be, or directly Vx3 is equal to, the polarity is opposite, so minus this voltage, which is 17.14, the voltage across this 30 ohm. Then 10 ohm into 10 ohm divided by 10 plus this 20 ohm. So this will be minus 17.14 into 10 by 30. Minus 5.71 volt. This is the value of Vx3, minus 5.71 volt. What we have to find? We have to find Vx using superposition. So Vx is equal to Vx1 plus Vx2 plus Vx3. Vx1 is equal to 14.281. 14.281 plus Vx2. Vx2 is, this is not 17.14, this is minus 17.14. So minus 17.14, then plus minus 5.71. So this will be 14.281, then minus 17.14, then minus 5.71. This will be minus 8.569. Minus 8.569 volt is the value of Vx. Use superposition to find VO in the circuit of figure. We have to find this VO using superposition theorem. As we can see that there are total 2 independent sources and 1 dependent source. Solution. First of all, we will redraw the circuit. Now, let's say VO is equal to VO1 plus VO2, where VO1 and VO2 are the voltages due to 10 volt and 2 ampere respectively. 10 volt and 2 ampere respectively. Now to find VO1, we will consider 10 volt voltage source. 10 volt voltage source and turn off all other independent sources. So this will be VO1. Also here this will be VO1. Now we are considering this 10 volt voltage source and turning off all other independent sources. So this is a independent current source. So this will be turn off and open circuited. Now this is a voltage controlled current source. To simplify this circuit, we will convert this voltage controlled current source into voltage controlled voltage source. So this will be this resistor is in parallel with this dependent source. So this will come in series. Here 1 ohm resistor, this will be 1 ohm. Now this will be V is equal to I into R. So I is 0.5 VO1 into R is 1 ohm. So this will be 0.5 VO1. Same value. But this current source will be converted into its equivalent voltage source. And the polarity will be, this will be plus, this will be minus, because the direction of current is in this direction. Now here we can apply KVL. So let's say this is current I1. So this will be positive, this will be negative, positive, negative, here positive, negative. So apply KVL to the loop. So let's say we will start from here. So this will be minus 10, then plus 2 I1 plus 1 I1, or directly 3 I1 we will write 3 I1, then minus 0.5 VO1 plus 4 I1 is equal to 0. Now this will be minus 10 plus this will be 7 I1 minus 0.5. Now this VO1 is VO1 is 4 into I1. So we will write 4 into I1 is equal to 0. So this will be minus 10, 7 minus 0.5 into 4. So 5 plus 5 I1 is equal to 0. So 5 I1 is equal to 10. Therefore, I1 is equal to 2 ampere. We have to find VO1. This VO1, and VO1 is equal to 4 into I1. VO1 is equal to 4 into I1. So 4 into I1 is 2 ampere. So 4 into 2. Therefore, VO1 is equal to 8 volt. Next, we have to find VO2. So to find VO2, we will consider 2 ampere current source. To find VO2, consider 2 ampere and turn off all other independent sources. Now when we turn off voltage source, that time it will be a short circuit. So this voltage source will be short circuited, and we are considering this current source, and this time we are finding VO2. So this will be VO2. Also this will be VO2. Now we will convert this current source into its equivalent voltage source using source transformation. So this will be here its equivalent voltage source. The polarity is upward, so this will be positive, this will be negative, and V is equal to I into R. I is 2 ampere and R is 2 ohm. So this will be 4 volt. And we will erase this. Also we will convert this dependent source into its equivalent voltage source. This resistor will come in series here. 1 ohm resistor will come in series. One ohm. We have already calculated this, so it get the same value because current is 0.5 VO2 into resistance is 1 ohm. So current into resistance is voltage. So same value. This arrow will change to polarity, and it will turn into a voltage source. So this will be positive, this will be negative. Let's say this is current I2. This will be positive, negative, positive, negative, positive, negative. So here we will apply KVL to the loop. So let's say we will start from here. So this will be minus 4, then plus 2I2 plus 1I2. So this will be directly 3I2 plus 3I2 minus 0.5 VO2, then plus 4 I2 is equal to 0. So this will be minus 4, 3 plus 4 will be 7, plus 7 I2 minus 0.5 VO2 is equal to 0. minus 4 plus 7I2 minus 0.5. Now this VO2 is 4 into I2. 4 into I2 is equal to 0. Now this will be 7 minus 0.5 into 4. So this is 5. So 4 minus plus 5. Minus 4 plus 5 I2 is equal to 0. So this will be 5 I2 is equal to 4. Therefore I2 is equal to 4 by 5 ampere. We have to find VO2. VO2 is equal to 4 into I2. VO2 is equal to 4 into I2. So this will be 4 into 4 by 5. Therefore VO2 is equal to 4 into 4 by 5. 3.2 volt. 3.2 volt is the value of VO2. Now we have the value of VO1 and VO2. We have to find VO using superposition, and VO is VO1 plus VO2. Now VO1 is 8 volt plus VO2 is 3.2 volt. So this will be 8 plus answer will be 11.2 volt. This is the value of VO. Use superposition to solve Vx in the circuit of figure. We have to find this Vx using superposition principle or superposition theorem. As we can see that there are total 2 independent sources and 1 source is dependent. Solution. First of all, we will redraw the circuit. Now let's say Vx is equal to Vx1 plus Vx2, where Vx1 and Vx2 are the voltages due to 6 ampere and 4 ampere respectively. 6 ampere and 4 ampere respectively. So to find Vx1, consider 6 ampere and turn off all other independent sources. Now here we can see that this 4 ampere is the independent source. When we turn off this 4 ampere current source, this will be open circuited. This will be Vx1. Now let's say this is node with voltage Vx1. Let's say this is ground. This voltage will be, let's say this is VA. This will not be Vx1 because it is not connected to ground. So here we will apply KCL. Let's say this is current IA. Apply KCL to node VA. Summation of all the entering current at this node is IA plus 6. IA plus 6 is equal to leaving current is IX. IX is the leaving current. Now IA is 4IX minus VA by resistance. Resistance value is 8 ohm. So 8 plus 6 is equal to Ix. Or we can write the value of Ix as VA minus 0 by 2. VA minus 0 by 2. Here is also, this will be 4 Ix by 8 minus VA by 8 plus 6 is equal to VA by 2. So this will be 4 by 8 or 1 by 2. In place of Ix, we will write VA by 2. VA by 2 minus VA by 8 plus 6 minus VA by 2 is equal to 0. So this will be 1 by 4 minus 1 by 8, then minus 1 by 2 or directly 0.5. So this will be minus 3 by 8 VA plus 6 is equal to 0 or 3 by 8 VA is equal to 6. So VA is equal to 6 into 8 by 3. So this will be 6 into 8 by 3. 16 volt is the value of VA. What we have to find? We have to find Vx. Vx will be equal to 4Ix minus VA. Vx1 is equal to 4Ix minus VA. So 4 into Ix is VA minus 0 by 2. VA minus 0 by 2 minus VA. VA is 16. So this will be 4 into 16 by 2 minus 16. So Vx1 is 16 volt. Also here we can see that the polarity of Vx1 is opposite. So this will be minus 16 because of the polarity. This will be like minus 4Ix then plus VA minus, or this will be plus. So here also this will be plus and this will be minus. So minus 16 is the value of Vx1. Next we have to find Vx2. So to find Vx2, we will consider 4 ampere. Consider 4 ampere and turn off all other independent sources. We will turn off this 6 ampere. Now when we turn off the current source, so this will be a open circuit. We are finding Vx2, so this will be Vx2. Now let's say this is node VB and this is ground. So this current will be IB, this current is Ix and this current is 4 ampere. Now we can apply KCL at node VB. So summation of all the entering current at this node is 4 ampere is equal to leaving current. Leaving current is Ix plus Ib. Ix plus Ib. So 4 is equal to Ix is Vb minus 4Ix by 2. Vb minus 4Ix by 2 plus Ib. Ib is Vb minus 0 by 8. Vb minus 0 by 8. Now we will simplify this. So this will be 4 is equal to Vb by 2 plus 4Ix plus 4Ix by 2 plus Vb by 8. Now this will be 4 is equal to Vb by 2. This will be Vb by 2 plus 1 by 2 plus 1 by 8. This 1 by 2 plus 1 by 8. 5 by 8. 5 by 8 Vb plus 4. This will be 2Ix. Now in place of Ix we will write Ix is equal to Vb minus 4Ix by 2. Or we will write Ix as it is. So this will be, you have to write one more equation. So from that we can find the value of Ix. Ix is equal to, let's say this is equation number 1. Also Ix is equal to Vb minus 4Ix. Vb minus 4Ix by 2. So this will be 2Ix. 2Ix is equal to Vb plus 4Ix. Now this will be 2Ix minus 4Ix is equal to Vb, or Vb is equal to minus 2Ix. Now we will substitute this value in equation number 1, or we will substitute the value of Ix as Ix is equal to minus Vb by 2. Ix is equal to minus Vb by 2. So this will be in place of Ix we will write minus Vb by 2. From this we can find the value of Vb. So this will be 5 by 8. 5 by 8. Then plus or minus, directly this 2 and this 2 will get cancelled. So minus 1. 5 by 8 minus 1. So minus 3 by 8. 4 is equal to minus 3 by 8 Vb. Therefore Vb is equal to 4 into 8. 4 into 8 by minus 3. 4 into 8 by minus 3. So minus 10.66 volt is the value of Vb. Also we can say that Vb is equal to Vx2. Vb is equal to Vx2 or Vx2 is equal to Vb. Therefore Vx2 is equal to minus 10.66 volt. Now we have the value of Vb, Vx1 and Vx2. What we have to find? We have to find Vx using superposition theorem. Vx is equal to Vx1 plus Vx2. Vx1 is minus 16 volt. Minus 16 volt plus Vx2 is minus 10.66 volt. So this will be minus 16 minus minus 16 plus 10 point minus 10.66. So minus 26.66 volt. This is the value of Vx. For electrical and electronics engineering related questions and answers, visit the link in the description below.